In this lesson we're going to deal with a very difficult file. The highlighted file up there. The parameters, it's a 1x probe, 2 volts per division, 5 microseconds per division. The ripple voltage is 120 hertz, 200 millivolts, and we did a priority post capture, which means all the data is after the trigger. But we'll assume for a moment that we did a priority equal, which means the trigger's in the center of the data buffer. It's too hard to recreate this exact situation, so I'm just going to use the post file, and we'll assume that the trigger point is 1800 samples in, and we'll assume that we want to look at something that's 1200 samples in. That part of the waveform is what we want to examine closely. We also have the additional problem of this being a very small signal and a large DC voltage, so we're going to have to do some amplification to get better results. So let's get started. First we'll go ahead and bring in this file the normal way, just like we did before in the previous lesson. And we'll select the sequence, throw it up here, select the value, throw it up here, and now we'll go to data and we'll XML import data from the same file. Now we have the data present. The problem with this method of getting to this point is that we can't separate these two columns. We can't make a chart that uses a third column. At least I haven't found a way. Maybe there is. I haven't found it yet. So my workaround is to export this data into a notepad file, and then we can load the notepad file and do what we want to do. So to do that, we select the column A. Try this again. Select column A and column B with the control key. We right click inside any column and click on copy. Now that placed all this data on the Windows clipboard. So we can go up now, go down I should say, go down here and start up Notepad. And we go up here and we click and we do a control V, which is paste. And that's the bottom of the data. And all the data has now been moved over to Notepad. And this is the top of the data. So now we save the file, save it as, so we can tell it where to go. We'll call it temp test. I already have it. So we now have the data captured into a Notepad file. So we can close Notepad. We have to close Excel to get rid of the XML maps. No change. No, don't save the changes. No, don't leave it on the clipboard. Okay, now when we start up file, we'll open the text file, but you notice it's not listed. We have to go down here and select all files, and this test temp.txt is what we want to open up. So you open up that file, and now remember we said we wanted to start it and look at something at 1200, so we'll start at 1150. No sense bringing in stuff we don't want to look at. And we'll say next. We'll treat consecutive as 1 in case they occur. And nothing here, so we finish. And now we have the data in here. Now we can separate the data and do magic with it. If you go to, since you didn't have a column B, you would select column C, go up here and insert a column. Now you would have a new column in front of what was your column C. That's how you insert a column. I'm going to remove it right now because I was just demonstrating. Edit, delete that column. So that's how I got the column B. Once I developed the column B, then I had to go ahead and create a formula. Formula is up here. I took the A4 value, 1150, and I subtracted 1148 from it to get the new value of 2. what this is doing, it's offsetting the sequence numbers. This sequence number 1148 will now look like sequence number 0 to the charting program. So we don't have to start with 0, we can start with 1148, but the chart is fooled because he thinks we're starting with 0. So once you create a formula that does something like that, then you copy the formula and you go over here in the column where you want to place it, and you simply highlight all places you want to replace it. Once you get that done, you right click and paste will replace it. I won't do that at this point. Then the numbers will magically appear. Sequence numbers starting with 0 or 1. So that's how we created that new column of data using the formula shown right here. Next, we created a new column D, delta, same way. And we wrote a formula for this, and this is a much more complicated formula. So let's see what we want this formula to do. What we want it to do, we want it to take an offset value of DC voltage. We want to use a portion of that offset, a percentage of it, to get a new DC level on the waveform. And we want to multiply the results by a gain factor, in this case 30. And we end up with what this is over here. So our goal is to expand the small ripple on the large DC voltage and still be able to see it. One thing that is different about this particular equation is the dollar equal dollar $10. What that means is use the absolute value of E10. As the rows change as you copy the formula, don't change this, leave it right there fixed at E10. So the $10 keeps it fixed there. Same way with the percentage. $11 it makes these formulas use that value no matter which row we're on. And then we divide the whole thing by 100. So we're taking the offset, we're taking C, which is the original data for that data point. We're subtracting this offset value, 15.2 volts, and we're multiplying by $11, which is 95%. Then we got to divide it by 100 to get rid of it. So we don't need a decimal and then 0.95 down. We just put 95 in there, and this represents the decimal. And then we multiply the whole thing by the gain shown down here in this cell, which is 30, $12. So it's a complex formula, but it works very well. So once we develop this formula, then you simply copy the thing. Once again, you highlight wherever you want it to fall, that cell, and then you right click and you paste it. And that's how I got all these numbers derived from this formula up here. So now I have a new column B, column D. I want to use the column B, column D to create a new chart that's more useful in this particular situation. Okay, to create this chart down here at the bottom, we just used original data, which was column B and column C, in the same way we've created other charts in the previous lesson. Now we'll give you this chart, and if we scroll down we can see all of it. You notice this starts at 0, goes up to almost 16 volts, and there's a sine wave on there. It's real small, so it's hard to see, definitely hard to measure. If you look at this chart, you notice that -2, -4 is on this chart. That's because up here I put in a -2, and Excel always adds another dimension to whatever you use. So as it says up here, it's fixed data, So that sets the bottom threshold of the chart. I'm going to change this back to 0 and watch the chart as I do it. If I set that to 0, hit enter, notice the chart dropped down. Now the chart starts at 0. one division down here. If I make it 1, you won't see a change because 1 is already, let's do example, -1. Notice the chart didn't change because you can still see a -1. There's a -2 below it. So as it says in this line here, you set this to whatever you want the chart threshold to start at. I'm going to put it back to 0 for this example. So that's what this particular row is for, right up here. Down at the bottom of the data set, notice this goes all the way up to 18. Down here at the bottom we have a fixed value 16. And that's going to set the y-axis chart top parameter. So let's change this just for a moment. We'll get rid of it completely. And go back to the top of the chart. And we're going to select something. When you select something, it recalculates the chart, one of these variables. So you notice that now the chart only goes to a little under 7. That's the actual data. It always adds another dimension, which would be 8. So we shrunk this thing vertically by letting the default value data control the top of the chart. If we go down here, and change this to 16, which would be our upper limit of the data resolution we want to look at, and we hit enter, and we go back up, and select something on the chart. It's already done. So now it starts at 0, goes to 16 plus the extra. So that's how you control the vertical dimension on the chart, with that bottom data point. And as we said earlier, the top data point controls the bottom position of the chart. When I tried changing the percentages, I found that the chart was not graphing properly. So I went up here and I looked at this formula. I found a mistake. So you have to redo your formula to match this particular line up here. I was subtracting the DC and then doing the average in percentage. You can't do that. You got to take the offset times the percentage, divide that by 100, and then subtract it from C4. Then multiply all that by $8.12, which is your gain value. And now the chart works properly. So let's exercise it a little bit. If you notice, as the percentage decreases, we'll take it down to 90%. The chart climbs up and it really disturbs our results. So you want to, most times you want 100% of the offset. Here's what you watch out for. If your signal starts going below 0, then that's too much, because you start magnifying negative numbers, and negative numbers go even deeper. So it's better to keep this so that the signal never goes under 0. So let's just move it up a little bit to make sure it never goes under. We'll make it 95.5%. Well, first we'll try 90%. Notice that's crazy. 99, like we said, brought it down to there. So let's do 99.5% reduction. Takes it down there, and I can live with that. Actually, I can't. 99.7. It's even closer. So as this percentage number increases, the waveform drops lower on the scale. And then the gain is simply the amplification of the waveform. So right now it's a 40 gain. So if we say that this peak value here is, let's call it 11 volts, then it's 11 divided by 40. So it's really a quarter of a volt, 250 millivolts from here, 0 reference, up to there. So you got to remember to back out the gain factor to figure out the actual value. So this ripple right here is probably in the neighborhood of 200 millivolts, and that's what we put on top of the 15 volt DC signal. So that's how you use this process. You need to go back over it. It's very effective. It allows you to look at trigger sampling in the middle of the buffer by stripping off the unnecessary stuff you don't want to look at. Get rid of the first 1147 data points. And we rescale the chart so he starts with sequence 0 instead of sequence 1148. and then we can do complex formulas on column D to show the results. At least we forget that now you've done all this fine work, we need to save it. Once again, you want to save it. You want to do save as because we want to change it to an XLS file. I had already loaded an XLS file for the demo because I started from the end and worked backwards. But you would right now have an Excel, you'd have a text file loaded when you started all this. So you need to save it as an XLS file, and always make sure that whatever the file name you use, XLS is the type of save as type. So we save it as XLS. Mine already exists, yours probably wouldn't. And now this masterpiece has been saved. You can load it back up and re-examine that waveform anytime you want to. This concludes the intermediate level Excel procedures for inspecting nano buffer files.